Assalamu alaikum. Today we will be discussing the methods to determine the coefficient of permeability of soil. Here we have some of the apparatus required for the constant head permeability method. Here we have these porous discs which are fixed inside the base plate and the extension counter. As you can see, the discs have perforations in them which allow water to pass through them. Then we have the mold in which we place our soil sample at the required density. First, you have to measure the internal dimensions of the mold as well as its empty weight. After placing and compacting the soil inside it to the required density and weighing them both together, we then get these filter papers which we place above and below the mold when fixing it in the assembly between the base plate and the extension counter. The purpose of the filter paper is to ensure that as the water passes through the porous discs, it does not wash out the soil particles with it. Once it is all assembled, these bolts are tightened to keep everything in place. Once the sample is prepared in the permeability mold, it is placed in the lower water tank in front of us, and the inlet of the extension counter is connected to the upper reservoir. As you can see, there is a scale provided here, H1, with a scale next to it, and down here H2 with another scale attached next to it. H1 is for the water level of the upper reservoir and H2 is for the water level of the lower reservoir. It is constant here at this level and at this level, and the difference between the two water levels is the constant head causing the flow of water. Now, as you can see on this side of the upper tank, there is an overflow opening at this height. This ensures that the water level cannot exceed this height. In other words, keeping the head constant. Similarly, in the lower tank, as you can see, there is another opening given that allows the excess water to flow out. Now, the mechanism for the entire setup is such that the water, it enters from the upper reservoir, and it has two paths. One, it can escape through the overflow outlet, and secondly, it can travel through the inlet pipe into the permeameter and through the soil sample. Because the soil sample is saturated, when more water is introduced into the system beyond the capacity of the soil at that density to hold, the excess water is released through the bottom of the drainage disc and into the lower reservoir, thus raising the water level. However, because the water level in the lower tank cannot exceed the height of the overflow outlet which is provided, that amount of excess water pours out of the outlet at the same rate at which it enters the system by passing through the soil. So for this experiment, what you have to do is record the heights of H1, as can be seen over here, 60, and H2, which is 15.5. We also have to note the temperature of the water. Currently it is 30 degrees. After this, you take a stopwatch, and the moment you start it, you grab a measuring cylinder and begin to collect the water that is escaping the overflow of the lower tank to measure how much water is collected in a specified amount of time. This can be 30 seconds, a minute, or whatever the required standard state. Currently I'm doing so for 30 seconds. Once done, you note down how much water has been collected. Here I have around 18 milliliters. Once you're done, you'll repeat the process several times for the same amount of time, and after that you'll proceed to your calculations.